Good morning students, hope you all are well. I, Hareeta Malani, working as an assistant professor in Electronics and Communication Department of MLB Textile and Engineering College, Bhilwara. Today, my topic to be discussed is in the continuation of the previous lecture, and the next topic is optical amplifiers in subject fiber optic and communication. So, introduction to optical amplifiers. As we know the meaning of amplifier means whenever the signal gets weakened or its signal strength is less, we want to give some additional power to that signal so that that signal is properly measured or properly heard. So that is amplification process. So why optical amplifiers are required? The optical signals from the transmitters are attenuated by the optical fiber as they propagate through it. Other optical components such as marks, couplers also add loss. After some distance, the cumulative loss of signal strength causes the signal to become too weak to be detected. Hence, we need signal strength to be restored. So, that's why optical amplifiers are required in optical fiber communication. So what do you mean by optical amplifier? Boosting of an optical signal without any conversion of the light into an electrical signal. So it is again an active device because here conversion of light will be required. An optical amplifier is a device which amplifies the optical signal directly without ever changing it to electricity. So next, what is the necessity of optical amplifiers? So why it is needed? It is needed to transmit signals over long distance communication. We can say greater than 100 kilometers to compensate attenuation loss. So this is the first necessity of optical amplifiers. Second, initially this was accomplished with the optoelectronic module consisting of optical receiver, regenerator and equalizer and an optical transmitter to send the data. So initially when this optical fiber communication started, instead of amplifiers, we use regenerators and equalizers to transmit and receive the signal. But functionally, this arrangement is limited by optical to electrical and electrical to optical conversions. And regenerators are not the proper solution because the process is a regenerator converts the optical signal to an electrical signal, cleans it up and convert it back into an optical signal for onward transmission. So optical amplifiers offer several advantages over regenerators. So this is the traditional optical amplification system in which losses are accomplished due to so many components used in the communication system, and again we are using a repeaters or regenerator in between. So that also adds losses, and every time we are using regenerator, it has to regenerate the original optical signal every time. So this is transmitter, receiver, and in between we are having optoelectronic repeater. System capacity limited by speed of electronic circuit. So this is a traditional optical communication system. Next, optical amplifiers and reasons to use the optical amplifiers. So first reason is its reliability. The components used are very much reliable and it functions very properly. Its flexibility, then it can be used for WDM systems. It is low cost, easily upgraded and having large gain bandwidth. A single amplifier can simultaneously amplify several WDM signals. So these are the reasons, or we can say advantages, to use optical amplifiers. Now we will discuss basic diagram of optical amplifier. So this is the basic arrangement for an optical amplifier, such as high signal gain. These are the features: high saturated output power, minimal noise generation and ultra wide bandwidth. Fiber amplifiers have become essential components for high performance communication system. So this is my input signal is generated. It could be electrical or any other input signal which is to be converted to optical by using some source encoders at the input side. Then we are using a fiber gain medium. It is launched, light is launched into fiber medium. We are using a coupler to couple the light. Optical pumping is used, and at the output we are having output signal. So this is the basic diagram of fiber amplifier. In all fiber amplifier devices, the spectral bandwidth and central wavelengths are largely defined by the atomic structure. The gain medium normally comprises a length of single mode fiber connected to a coupler which provides low insertion loss at both signal and pump wavelengths. Excitation occurs through optical pumping. Why this pumping is used? Because here emission process will start, because we have to amplify the weak signals. So we are giving some excitation, external excitation to the fiber. So excitation occurs through optical pumping from a high power solid state or semiconductor laser, which is combined with the optical signal within the coupler. So these are the significance of basic diagram of fiber amplifier. So these points I have discussed. So next, what is optical amplification and its types? What is optical amplification? I discussed. Now variety of optical amplifiers. So there are so many types in which the most used is EDFA. So we will start with the classification. First classification is semiconductor optical amplifier, and it is used in the bandwidth range of 400 to 2000 nanometer. Second is optical fiber amplifiers, EDFA, which is used with 1500 to 1600 nanometer bandwidth. Next is distributed fiber amplifier, that is Raman amplifiers. We all have studied Raman scattering process, so that is used over here. Next is Brilliant optical amplifier, and among all this, majorly we use is erbium doped fiber amplifier, that is EDFA. Next, these are the applications. Why amplifiers are required. Amplifiers are required at the transmission side, near the communication channel side, or near the receiver side. So if we are using at the transmitter side, we will require inline amplifiers or power boosters. If we are transmitting the power which is weak, we will use power booster amplifiers at the input side. Near the communication channel, we can use inline amplifier. At the receiving side, I will use preamplifier. In this way, the applications are categorized. Now, how to select amplifier? Which type of amplifier we will require for the communication channel? The first is power amplifier, which provides you high gain, high output power, and its noise figure is not of that importance. Inline, medium gain, preamplifier, low gain. So next, optical amplifier functions. In this we are showing all the three amplifiers. Transmitter is transmitting the signal, optical light is transmitted, it is amplified or boosted by power booster. After that, the signal is transmitted through the communication channel to the optical fiber link, where we are using inline amplifier to get the proper output. It should be in line at the receiving side. While before receiving, that means optical to electrical conversion at the receiving side, we are using preamplifier. So detector, preamplifier. Next is stimulated and spontaneous emission process, because this is a key phenomenon behind signal amplification. Without this emissions, we can't achieve amplification. So this emission process is of 3 steps: absorption and emission. Emissions are of 2 types: stimulated and spontaneous emission. First, we will discuss absorption. Absorption means, if we consider energy level diagram, we are considering 2 energy level states, E1 and E2. So in absorption, an atom in a lower level absorbs a photon of frequency h nu and moves to an upper energy level. So it absorbs the energy and transmits it to upper energy level. Spontaneous emission, it takes place without interaction with other photons, and the direction and phase are random. It is used for non-coherent transmission. Incoherent transmission. Stimulated emission, it takes place when the excited electron interacts with another photon by the emission of photon of same energy as that of incident. So these are the definitions. Spontaneous emission, absorption, you understood. It absorbs the energy from E1 and then the electron is moved to E2 level. Spontaneous emission, excited electron is present in E2 state and it will randomly come down to lower energy state while releasing an electron. Electron release is incoherent process. Next is stimulated emission, a transition from higher E2 level to even energy state produces an additional photon with the same